In today's video, we will be discussing Physics 251, Week 3, Video Explainer number 23. This problem is essentially dealing with vector algebra and a little bit of derivatives, but I would say for the most part it's largely conceptual. So what we're going to be looking at is a function that is position of a particle as a function of time. It's kind of important that you note that it's as a function of time here. So I have that underlined. But what I have done is I've pulled out all the givens here, and then the problem asks you to kind of manipulate the equation and use different values to find different distances and velocities. So one thing that I want to note before we get into it is that for part B here, we want to remember that velocity is the derivative of position. And we also want to remember this magnitude equation here for a given vector's magnitude. If you have any questions throughout this explanation, I would refer back to Week 3 lecture notes, page 31 of Professor Yu's slides. It would probably give you a little bit more direction. All right, let's get to it. So for part A here, what we're going to be doing is plugging in values for time into our function relating to position. So from here, we're, as we can see with the I hat and the j hat, we're using unit vector notation, and there's no k hat because this is only 2 dimensions. So here we have our equation, as we can see here, and I'm plugging in different t's, different times, time 1, time 2, and time 3, into the equation. And since, as I said, it's a function of time, we have this kind of RT here. So anyways, we're going through and we're kind of simplifying out algebraically. And then once we get to this kind of final unit vector notation, we plug it into the magnitude equation to get to the exact magnitude in meters. It might be tempting to just kind of leave the equation in this unit vector notation. However, it is not complete, and you want to make sure you're going for the raw number there in the SI units as distance. So I did that for these 3 here. In this next part of the problem, we're taking the derivative of the equation because, as I mentioned, velocity is the derivative of position. So here we have our equation. We're taking the derivative with respect to t, of course. And as you can see, we're kind of going through the process. Here's, again, the derivative of position as velocity. So now we're kind of taking this t and taking it down, multiplying it in front, and we're left with this equation here. Vt equals 10 I hat plus 8 j hat times t. From here, we can use this equation for part C, and all we're going to be doing is the same thing that we did in part A of the problem, just kind of plug and chug and solve algebraically. So as you can see here, I've solved for all 3 time values and doing the same thing where I'm being left with unit vector notation here and then plugging it into the magnitude and then getting the actual number in meters per second, the SI unit for velocity. This problem can maybe seem a little bit complicated at first, but you just kind of got to remember the basics and really got to read into what they give you. So thank you very much for watching, and I hope this video was helpful.